So my name is Guansong Zhang, and I'm from AMD. So I think most of the people know AMD is coming back to HPC. But in terms of OpenMP, we are relatively new. So tonight I'd like to share some of the ideas and the thoughts we had when we try to implement OpenMP on our system. When I say our system, that means the GPU. And specifically, I want to say something about offloading, the OpenMP offloading model on GPU. And I put, a lot of people here know me. AMD is new to OpenMP, but I'm not. I spent like 10 years, more than 10 years in IBM. And most of the time, when I was there, I was working with OpenMP. So I put a disclaimer there. I'm trying to say the ideas, the opinions here, some probably just from the author may not be representing AMD. And also have Greg Stoner. I think I saw him somewhere. Okay, there, on the list. So okay. So here is some of my thoughts why we come to OpenMP. I can make this really quick. I think most people understand what I'm talking here now. Like it's a well-known industry standard, and I can list many names under this bullet, like IBM, Intel, and Cray. There are many of people vendors actually actively producing developing OpenMP compilers, and it gave user a wide choice for their computation need. So this is the vendor side. The second bullet I want to say, this is really about the OpenMP user. I think this is one of the best parallel programming model, because it supports this what I like to call this incremental parallel programming. The idea there is just that you have a sequential program, and then with one or two lines of change, then your code become parallel. I think Intel today in the booth run a very interesting demo. They have two groups competing to show how fast you can parallelize a code, and you got how many numbers, 40 times speed up, and both groups use OpenMP. And the third thing I want to say is this is a foundation for the tool developers. If you work on the software tools, you can actually do extensive analysis on the user code and find out the hotspot, and then point out and give user the hint how to make them parallel. And once you identify those hotspots, using OpenMP directive to change them into parallel is quite straightforward. With that, I want to mention the second point, why we want to do GPU. I think the key point is those two things. You see many people in the downstairs in the hall, in the exhibition hall, show the computation power there. I think in the end, GPU will produce the best performance per dollar per watt. So here I try to do an outlook of the GPU programming. You can see, I try to split the GPU programming into two kinds. You can do explicit kernel developing, or you can do implicit kernel developing. Because either way, eventually you want to use some kind of kernel running on the GPU. And in this slides, I'm trying to save up some of my voice. I lost it already. Like in this slide, I'm trying to say the OpenMP is one of the simple thing in the all the category. It may not produce the best fast program for you, but it certainly will be the simplest. So here is the summarize of the highlight in my mind on why on the advantage and disadvantage OpenMP had on the GPU system. Like GPU has the massive parallel cores is not available on the regular CPU. And not only that, it also can parallelize your memory operation. For this point, like I think I used to work on CPU, I kind of have some how to say this? I have some experience on this. I realize the GPU has this extra advantage on the memory access. But we also have issues, of course, like when we do the GPU programming, right now we don't have enough tools, like all the debugger, compiler stuff. I mean profiler. Here is trying to back up my point. I steal a slide from our sales team. This is trying to compare NVIDIA and AMD, but that's not the point. If you are like NVIDIA team, don't be offended. Like I just grabbed something and try to say the performance per watt and the performance like per dollar is GPU has unique advantage. And also, this page I also steal somewhere. This is AMD unique thing, and I have to put it here. And through this, I want to say three things. First, when you have the HSA device where you share the CPU and the GPU memory, all the pointers in your parallel region will work naturally. Second thing is the memory, from the GPU perspective, you have more access of the memory. And then the third thing is you have platform atomic. So on the GPU side, you can do atomic operation as well. And here is a summarize of what AMD had done and what we will do. We partner with we had a Pascal team as our partner. We tried to release the Intel compiler 2014. And for the details, people can visit AMD booth and we can talk there. We also participate the cloud LLVM effort Andrew just mentioned. And we want to release that on our HSA system. And the final thing, just to show some preliminary number on our FilePro cards. And this is trying to do a comparison between PGI compiler on our cards and Pascal compiler on our cards. And the red is ours, and the bigger, the better. And that's all. Okay, thank you.